now we're going to see the constructive and destructive interference with a thin film. First, we need to see what is the optical path length. Here, suppose we have a surface. Well, actually, could be a film. Here could be air, and here soap or whatever. We have at normal reflection or normal incident angle, that is, here is coming the light. It is perpendicular. Sometimes it is drawn a little bit inclined, just for clarification, but it's normal, so it's perpendicular. And then this can reflect, and then reflect again and pass here. Could be refraction. Refraction is when we change from a medium to another, or can reflect. So here we will have destructive or constructive interference. Remember that when we change the medium, the wavelength changes, the frequency stays the same, the wavelength changes, and so the speed of propagation. So if we have the wave something like cosine of kx or kd of distance traveled minus omega t. So if this in the air, the wave traveled a distance d, what actually the wave passing through the medium, this new medium, is traveling. So because we have lambda change because of the refraction, so the n is the incident of refraction, then the k you can see it as 2 pi over lambda d. Then lambda, the new lambda would be lambda over n. So we have 2 pi n d over lambda. 2 pi over lambda is k. So actually the phase would be n d. This is called the optical path length. So with thin films we can have this phase change, but also the phase change that will arise again for the index of diffraction. This would depend if we have n1 greater than n2 or if n2 is greater than n1. We will talk about this also in future videos. When we have destructive interference would be when our phase change, as we found in the double slit experiment, that is kdx or kd. If this is equal to a odd integer of pi, it is destructive interference. If it is equal to a even integer of pi, it would be constructive interference. And so we need to take into account the both ways in which we can have a phase change.